Good morning, folks. I got some good rest. I've gotten finally able to get a little bit of exercise in as well. Bike is going to be great the next few days while my knee is healing up. I'm feeling good. I'm going to take a quick couple look at some experiments. We're going to probably mess with the tiny boxes a fair bit today. A few other things around shipping 3.0, and then hopefully we'll be able to also work on the sim a little bit as well. Get rid of that bot that's instantly in this friggin' chat. And here we are. So first things first here, we've got these breakout results, which are like, it works, but it's slow. So I think we'll queue real quick. Okay. So we got this result in here from Grid Repro. We'll just do breakout, single, fast box, whatever. This will be puffer breakout. Okay, so now this, hopefully, we should see some sort of a difference there. And we'll see if that's just hardware differences, basically. Now on grid, as we can see, we've mostly closed the gap with our old perf. Now, I think there's a very slight gap, perhaps. Maybe a very, very slight gap still, but it's like, this is good, we can ship it. Yeah, like, this is good, we can ship it, basically. This gives us 11 runs that are above 0.9. Here they are. We have 0.96. That's pretty good. Pretty good. So, I mean, the solution there was to remove a feature, which is kind of fine. We'll wait for breakout to run to see if this is actually going to be a stable fix. If it is, this solves like multiple problems for us at the same time, though. And then if this is good, then we'll start going back and rerunning a bunch of sweeps with this, and we'll see if we can get any like better baselines out of it. We still have some problems left. A lot of the problems that we have, though, are going to be resolved pretty easily just by getting the new tiny boxes running, honestly. Because, like, that's going to give us enough hardware to run all our experiments. We can run scale-up tough stuff. We can do a lot with those. So let's see if we can figure out the tiny boxes. Welcome, SPY. I will excuse you for being stupidly cringe because you will probably continue to be stupidly cringe into your early 20s. I know I was. Though not in the way, not in that way. I got some great Blunder Years pictures. We'll see what George sent me. Oh man, I did all sorts of crazy things. When I was an undergrad, they had this like stupid dorm president, dorm this, like they had like these stupid roles. I thought it was dumb, so I jumped up on the stage and with a jester's hat and gave like the most ridiculous over the top speech in say Shakespearean prose and applied to be the dorm fool. Let's see. I had an I had a like an English class that was required in college that I thought was kind of dumb as well. So to entertain myself, I showed up to every class with a bandana on and like a flannel shirt, and I spoke with a god awful Southern accent. But because most of the people there had never actually heard anyone from Texas, they all thought I was just from Texas. I did a bunch of dumb stuff, man. Yeah, don't do that. Yeah, that's not called being cringe. That's called being a sex offender. There's a slight difference between those two things. Yeah, alright, enough of that in my chat. Thank you very much. We're doing tech, man. Currently, we are working on, getting... Actually, fucking hell, get that off my screen. This is a text. We're getting that off my screen. Actually, can I just reset the chat? See, you make me have to go figure out how to freaking reset the chat, man. Thank you very much for that. Yeah. I'm not banning you because I get it. You're just that age, and it's like... And I do hope that there's cool tech here that you can learn stuff from, but geez, get your ducks in a row. Thank you, Alex. Yeah, so what we're going to figure out today is we're going to see if we can get the tiny boxes to actually run GPU jobs stably. And if we can do that, then we'll have 12 GPUs for running all of our release experiments very, very quickly. And we should literally be able to just release this thing within a few days of work. I'm sick of having this in pre-release. This needs to be done. But, like, we've just had so many bugs and things. So, like, the experiment's looking good now. I think with this, if we can actually get it to be stable, we'll be good from here. Trying to use Puffer for my research these past few days. Hey, just drop by here or the Discord if you have questions. I'm hard at work here trying to make it. I mean, trying to fix reinforcement learning as a field, really. 3.0 is really, really solid. And we're also, like, just starting to make some crazy new environments too, given that we have tech able to work with stuff. I already replied to one of my messages. You have a different username in here? Oh, here. Run speed. Wasn't using demo.py. Yeah, so if you use the... Oh, you were just using the vec? Okay. I mean, watch this. Okay, let me reset this container because this... Stop. So the thing is, it's not just PPO. Like, we have... I mean, to be fair, we have not run a sweep in a while on, like, the actual Atari M, since we have our own versions of Atari that just, like, train at millions of steps per second that we use for our work. But we do have bindings for actual Atari. Let's see. Puffer, train, puffer. Or no, not puffer, just breakout. Then I do pip install. Grab Atari. Yeah, I get the desire to stay as close as possible to CleanRL because CleanRL is very, very good. And we built our stuff, like, starting with CleanRL. It's very, very difficult to keep quite that level of simplicity, you know, when you are doing all the stuff that we are. But we do have, like, a single 1,000-line train script that kind of does everything. So it's not that far off. And, yeah, there you go. So there's breakout at 40,000 steps a second. Like, actual original Atari breakout. So that should be right there, like, 10x plus faster. Specs. This is just a local box I've got. This is 4090, and the CPU is a 9950X. We did numbers for this on, like, I think on the paper, actually. Okay, so we had, and I think we've actually made it faster since then. We had 25K with Puffer versus 4 or 5K with Gymnasium. I'm only getting 10K. Do you have it set up with all the workers? You got to set like 16 workers, and then here, 6K after Puffer. What do you mean after Puffer? Something's weird there. Are you using our multiprocessing backend? Because it should be way faster. So like, look, for Atari here, we typically will run like 128 Ms. We do 16 workers and like a batch size of 64. You don't have to do this part, but this is asynchronous double buffered, so this requires you to change your inference loop a little bit. You can also set it to 128 for synchronous. And then you'll get, where is it? Yeah, so we got like half of that, like 12K. So it's still twice as fast even in synchronous. And there's also, I mean, you can also just use this from the, you don't have to use just the config stuff. You can also use, you can just use like vector.make or whatever and do it raw. And in fact, that's kind of what we intended early on, is we just wanted to provide like low-level tools. So like, you know, we wouldn't force you to use like a fancy config system or anything. But what kind of happened is our implementation got so good that like there was literally no point in us doing anything with like existing CleanRL or SB3 or whatever, because our implementation is just so much better at this point. So like in 3.0, okay, we have like 1,200 lines, including all the spaces. I believe it's like 1,000 lines total. And this just solves everything. Like, this is, it's based on PPO, but it's much, much better, both algorithmically and performance-wise. I mean, here, look. So this is our version of Breakout, where it runs fast and from local state. And there, I'm training this at 3 million steps a second. So, like, this is just learning the env before your very eyes. You can actually see the episode return, the score. Probably should train it for a little longer. But, I mean, still, you'll be able to see if I just puffer eval. So this is the model that I just trained in the last 30 seconds. What did you guys add on top of PPO to get it better performing? We added a lot of stuff is the thing, right? It's not just like a couple lines. We have our own custom advantage kernel that combines GAE and vtrace. We've got advantage filtering, trajectory segment level advantage filtering. We've got prioritized experience replay over the samples within this, like within the current batch. We've got a different optimizer. We use muon by default. We use cosine annealing for learning rate schedule. It's a lot of stuff. You know, we've done quite a bit of research in this area. It's been going very well. I mean, the fact that we can just like, we can train cool stuff in literally 30 seconds now, right? This is the new environment I've been working on. I've been working on like this big tactics environment with all these armies. That also will train it over 1 million steps a second. Like, I worked on, that's taken me like 3 days, basically. So, like, we're kind of just positioned at this point to be doing absolutely crazy things with reinforcement learning. And, like, as much as I like to keep things, like, the whole thing with Puffer, right? All of my stuff is about trying to keep stuff fast and simple. So, like, I actually kept the CleanRL, like, just the CleanRL compatible version for quite a while. Because I love CleanRL. It's the best thing in RL. I know Costa personally. He's awesome. But, like, we're kind of just at a point where we need to go 100 times faster than CleanRL base allows us to do. And that's kind of what we've done here. And then we've optimized the full stack so that, like, you know, from building new environments to simulating them in parallel to training to logging, like everything is super compact and fast. So like, yeah, when you replace the whole RL stack, you're going to end up with a few thousand lines of code, but like our few thousand lines of code replaces like all of SB3 or all of RLlib or like, you know, all of those or all of Gymnasium's like fancy tooling. Like it really does a lot for what it is. Hey, Boxen. Why is this suddenly stable? Can you do something? So he did this. I did that PR. Sure, 1 second. That does. Then I got Aaron wanting to chat. Set an alarm so I don't forget about that. This one, Boxen? Good. Does this thing train anything yet, by the way? Okay, this is better. Up length. Something like that's fine. They do learn to harvest. Good. Yeah, okay, this looks fine. I don't see anything wrong from first glance at this. I'll merge this in. This doesn't touch anything else. Thank you. Ooh, Jasin made a PR on Robocode. Dude. What did you do, my man? Oh. $40K lines, yep, the entire size of PufferLib. The entire size of PufferLib. So this thing, it looks like it's stable. I've tried to implement quite a lot of exploration stuff. Specifically, Diane didn't get it to work really well. I think. But yeah, like, I think I've got it down to I have the thing that should be science down to an actual science on how to test algorithms like that. You absolutely don't want to like make a new env like CPR, or was it common pool resource, and then like try stuff on that to see if the new algorithm works better. Because you're gonna have like simultaneous env bugs. You don't have a baseline. There are a bunch of problems. You want like a stable, scalable problem like maze, okay? And then you're gonna you can use stuff like that for maze if you want like a pure exploration algorithm. That's gonna be a good test. We need like even simpler ones. Just see if you can make, for instance, just like empty room, have the puffers go in different directions, stuff like that. Research is on exploration. Well, let me show you, do we have the policy for this? I think I'd have to train it real quick, but I'll train it for you real quick. I'll show you what we have. It'll take, it'll be done in, you know, however long that takes. I'm gonna check this in the meantime. We got a pretty cool maze policy that I think you're gonna find, pretty interesting to see. Because I think we have best exploration out of the box with Puffer. Like the advantage filtering. The advantage filtering that we do implicitly helps with exploration a lot. We don't have count-based exploration is the thing. We don't have other signals like that. It's literally just negative. It's just 1 for finishing the maze. It's about memory and like It's like coherent memory, right? But that's a lot of what actual exploration is, right? You try a thing, okay, that doesn't work, I try another thing. Very long corridor is kind of a stupid problem in a sense, because if you just make it long enough, then it's like it's a combination of this looks really simple but is actually impossible, because like I guess it depends. One really long corridor, sure. If you modify that problem slightly, so you make it branching, okay, so like you can choose left or right, and then you can choose left or right, it basically becomes a password guessing problem, right? And that's actually algorithmically intractable. See my DM. What you DM to me? Did you DM me on? Oh, Discord has the worst DM request system ever. Link me the C code, man. Updating 1024 buffer should still easily be a million steps a second. Is this thing just randomly stable now? Is there a way to run demo.py from remote and see the trained agent play? Yes, but that's not a PufferLib problem necessarily. That's like having graphics forwarding from your remote. Frankly, what we do, it's way easier to just have a local setup and then just pull the model file down than like having to deal with remote rendering, because it's just janky and it's always configured differently on different machines. So what we do is we have the same exact Docker container that we use on our servers. We just have a copy of it locally, and then it's super easy to just pull model like policy down. And the Docker is already set up to have rendering pass-through, so you can render from the Docker. What happens if you don't use big enough BPT? I don't know, you could try it. But the thing is, BPT and JE Horizon are linked in the current version of the code. They're not like they're no longer separated. You can't really test one easily without the other. Right, X11 forwarding, but Raylib. Yeah, I would just, if you want to get that working, I would try outside of PufferLib, just try to like run one of the Raylib samples and get it to render remotely. And then if you get that to work, then it'll work in PufferLib, basically. And if you do actually figure that out, let us know, because that would be nice to have. But generally, it's been way easier to just like, render locally for us, at least. I don't know. If that can be made to just work though, that would actually be pretty nice for us. Did you fix advantages segment bounds in 3.0? Advantages segment bounds. I think it's made irrelevant by the way that we do segments in 3.0. There are no bounds in 3.0 because you just collect one segment worth of experience from each env in basically every configuration. I think technically they're not fixed if you don't do it that way, but in all of our configs, we just have it set so that, like, you're basically collecting a fixed number of steps of experience from each env, which is the way that CleanRL does it originally. It's a little less flexible than what we had in 2.0, which is why I had this way more flexible thing in 2.0. But going back to this for 3.0 lets us do the advantage filtering, and the advantage filtering's been really worth it. What's the difference between vecnumEms and envnumEms? Yeah, I'm sorry about that. That's confusing. I don't know how to name it better, though. So vecnumEms is going to tell you the basically the number of instances of your Python class to run, your Python environment class. Now, the thing is, because loops in C are faster than loops in Python, in practice, like, all of our C environments internally can run multiple copies of themselves. So if I do like vecnumEms 2 and then envnumEms 1024, then it's going to run 2 vector instances, each with 1024 internal C copies. And then the thing is, you can run these asynchronous. So like one group of those 1,000 environments runs at a time, and then in the background, the other ones are running, right? So if you do it that way, then you basically, you always have, even when the model forward pass is running, you have the other envs running in the background, and you drive CPU latency to 0. Yeah, envnumEms gets passed to Python. So anything that you put into env, like the env config, will get passed as a parameter to your environment. Also, neural MMO has run 1 billion steps while I've been yapping. I don't know how this thing is randomly stable now. VecnumEms 1 billion, holy. Oh man, you haven't seen anything. Like, this is, look, I would make everything even lighter weight than it was if we didn't have, look at this. Okay, this is a soda run of neural MMO 3. This x-axis, that's E11. That's 120 billion steps. This runs in like 12, 14 hours, I believe, on one tiny box. We're gonna do a trillion step run of neural MMO 3 soon. I think maybe we might do even 2 trillion, because then that would make us, that would be more steps than all of OpenAI 5 was trained on, all of Dota. These are just things that we can do now. Like, reinforcement learning actually just works. And this is a soda policy that's like almost 3 times as good as previous soda. Also, I've attached you the env code. Way easier when you link GitHub, but I'll look at it. Let's put it here. Where's max agents? Where is max agents? Okay, so you shouldn't be doing gets passed from the binding. What? Oh, you named this like a constant, man. But if this is a big number, like you shouldn't one-hot encode in the C environment. Okay? Like it looks like these are all one-hots. There's nothing that's floating point here, is there? Is there even anything floating point? Or are these just all... These are all ones and zeros, right? Oh yeah, dude, you can make this thing so much faster. The tape is... Okay. The tape is floating point? Eh. Well, there's technically a way around that as well. But for now, okay, we'll keep it in floats. Technically, you can make it 4x less memory overhead. Almost. But, like, how big is the tape? Are most of the observations from this stuff? Because, like, you probably shouldn't be doing one-hot encoding in the environment. Okay, what you do is you make these, like, uint or whatever, or you just assign the index, and then you do the one-hot and the forward pass of your network. We do this for a lot of our environments. Because it reduces the GPU communication bandwidth, right? Like if you one-hot into 8 different things, for instance, you reduce the GPU bandwidth by a factor of 8 just by one-hot encoding on the network. Tape size is 1024. Oh, okay. Well then, here, like, there's so many easy things you can do. Like, why isn't this a mem copy? Right? Like, you're doing everything in loops when you have, like, big contiguous chunks of memory, and you can just do this as a single mem copy operation. Like, this is one mem copy. I mean, that probably alone will just get it, like, make it work. So yeah, you run a basic profiler on this thing, right? You just, like, go run C profile on this, or G profile. And then, like, basic stuff like that'll make this thing easy million. Have you seen latest? I have not seen any Fireship videos. Yeah. I don't see anything here where it's like, oh, this has to be on the GPU. You're also allocating in the dynamics, it looks like. Yeah. We usually pre-allocate. Yeah, I don't know what the hell's up with this box, because it seems stable, where it definitely was not stable before. Oh. Is Alex still here? Load, model, path. Okay. Here you go. This is our maze agent. If you've worked on mazes, you know how ridiculously good this is. This literally just gets a 1 reward for getting the goal and nothing else. And it just sees a tiny little local crop of tiles around itself. Like, look how ridiculously coherent this thing is. If you do not work on reinforcement, like if you've never tried to do RL on mazes, this will not look particularly impressive. If you have, then you know what this is. Not going to get all of them. Like, this one is pretty hard. Buffer stuck. Yeah, it's stuck because this is the amount you have to backtrack. You have to go all the way to there. Specific requirements. Well, I mean, it's like if you want to do research on exploration algorithms, there aren't any requirements. If we were to add an exploration algorithm to Puffer, like we're not going to add stuff that we don't think is like generally worth its weight for RL, right? Like there are a bunch of these fiddly exploration algorithms that are kind of hacked to a few problems that like slow your code down and add a bunch of like jank to it. We're not adding that stuff. But if we find something that's like, oh, okay, this genuinely helps, right? Then that's like, then we'd add it. Have you basically solved credit assignment? There's not really any such thing as solving credit assignment, really. Like, credit assignment is itself AI complete. It's just better overall. By a lot. If it's a win for more complex environments and it doesn't slow down the rest of our stuff and it's not crazy, like, it depends on the result, right? It's like the methods, you have to justify the complexity of the new method with the result, right? So if you just take this thing and it doubles the performance on neural MMO3 and like, it makes our mazes twice as fast and stuff, then I'll be like, oh, that's a good method. It's like, well, it doesn't help on breakout because breakout's easy. Fine. Is there a way that we can at least do it so it doesn't slow that down? That would be nice. But like if it's it kind of does a thing sort of on neural MMO and it kind of just slows down the rest of this stuff, it's not so good. If I have to implement Dreamer, that frickin' Dreamer paper, to get a model of the environment. Well, the thing with Dreamer, right, is like I don't even know that it's good. Like I literally don't even know that that's good. Cuz like from a wall clock time, their results suck. Like they use a ton of samples. So like and they make everything really slow. All the tricks that are implemented in that paper are horrible science. It's like a complete hack job. The reference code for that paper sucks. It's like atrocious. So like there might be something in Dreamer v3 and adjacent work that like I could be convinced, yeah, this is going to be the thing that we want. But like it would have to be done substantially better than the Dreamer paper. So yeah, Alex, if you're seeing these grid results here on this maze, I mean, like, let me just kind of put this in perspective for people. Maze. Okay, these are what the mazes that look like usually that people use for this research. I think this is like one of the biggest ones. So like, yeah, it's dramatically better. Do star the puffer though, for folks on Twitch. This is all free open source dev. You can literally get involved with this right now by joining the Discord, but at least star the puffer. It helps us out a lot. I work on this stuff full time. 21, 18 stars. Not bad for about a year's worth of work. Yeah, we're fine with new people as well. We've trained quite a few people in RL. Okay, this neural MMO run actually seems stable, which is weird to me. I guess what we'll do we'll do this. Tiny at tiny box. Wait, how is it tiny at tiny box? Tiny puff 1. Okay. I actually might do some like Dreamer adjacent stuff. I'm not opposed to it. It just has to be way better executed than the original Dreamer paper. And yes, if I sound a little bit annoyed about it, it's because we burned 10,000 GPU hours, and like I kind of dragged a bunch of my friends into a nightmare of ablations because I trusted that like the authors did reasonable science on that paper, and it was just horribly done science. They basically did like this big presser, and like they created all this freaking hype, and the science just in that paper was just awful. So like I don't know. Academia in RL is such a shit show, man. Like, academic RL, it's basically just sales. Like, nobody gives a damn about actually doing real science. The people who are trying to do real science are trying to do it wrong because they've got, like, all these twisted notions of what they need to hold fixed to compare against other methods. And, like, none of them can do any real engineering. It's a mess. And this is why I'm here doing this stuff, right? It's because it was such a mess. And like I spent 5 years in my PhD fighting this and fighting this and fighting this, and finally it's like, okay, enough, right? Like I can't do this work this way anymore. RL is important. It's a really awesome area of AI. It's going to unlock a whole bunch of new tech. It's not going to happen if we keep doing it the way it's happening in academia. We're building PufferLib. Let's say the algorithm paper is about unsupervised exploration. They show how it generalizes to other ends. What can you do instead with Puffer is that you replace the environment reward with exploration reward. You have a schedule which lowers the very naive. That works. Offline exp. You can try stuff like that. Yeah. What would you recommend to trying to do RL research? It depends how new you are. But I have a little guide here that I recommend because it's very accessible, and this is a very good way to just start doing useful work quickly. So this is on the website. I will probably update this soon, but it's a decent guide. And I mean, I generally just suggest getting involved with the stuff we're doing in Puffer, right? Because like it's a little bit self-serving, but this is legitimately what I'm doing, right? With all of my time right now. I don't do other things. I'm trying to make reinforcement learning sane and stable. And the way I'm doing work right now is the way that I think we're going to advance the field. So it's uh, I mean, there's a lot of environment dev. There can be, to be fair, I'm doing some like industry adjacent environment dev because they're harder environments, they're interesting, and like also financially we need to pay for servers. But I think on the like the more pure science side, there's a lot of room for probe environments, like test environments, to see specific different learning dynamics and how our algorithms interact with them. There's a lot of room for like very carefully and correctly across all of our fast environments, testing out different ideas from literature, testing out like world modeling stuff, testing out search stuff. There's a lot of things that we could potentially test. It just needs to be done to a way higher standard than is done in academia. And the way that we do that is by making our experiments 1,000 times faster so we can actually run enough of them to convincingly show something. That's pretty much the gist of how what I'm doing works. And handholding is fine. Like I will help people who are actually sticking around and doing work, basically, right? Because I get a fair number of people who seem to just want to like sit on Zoom calls with me all day and like have me tell them stuff, but not actually write anything. We don't do that, Like I like people who are actually involved and like actually trying to work on stuff, though. That's good. Like, you gotta listen to some of the things, though, right? Like, you can't be allergic to doing low-level dev. It's just very, very difficult. Like, I have a couple people that I actually work with who can't do low-level dev, but it's so much better if you can. And basically, you have to be a math or a science genius, uh, if you want to get away from the low-level dev and purely do that side. The low-level dev is just so useful because you can self-contained, right? You can have your idea, you can implement it, and it's relatively simple low-level dev. Let's be real here. You can implement it. You can do the full stack basically of experiments. So it allows you to be mostly self-sufficient, and then you just need input on like correcting things like screwing up rewards or screwing up like problem formulations, things that take more time and more experience in RL. Like, that's fine. I do that for a bunch of people. That's probably the best way though to be effective, is to be able to have the full loop, and to get good at that as quickly as possible. Mem copy instead of for loops, just for the really big blocks of stuff like that one tape, yeah. And no one hots and env code. It depends how big they are. If the tape is most of your observations, then it doesn't matter. But like, the size of your observation buffer does make a big difference. So if you have a 1024 tape and then you have another like 4096 of other things, definitely don't one hot those. I mean, it's like, you don't need to forget, like, it's very simple, right? Like, the amount of bandwidth that you're going through, right, is equal to the size of your observations in bytes times the number of steps per second that your training is running. Okay? So like, you can do the math and you can see that very quickly you're up to like gigabytes of communication, and we have stuff pretty well optimized, but like, there's at least like one extra redundant transfer because we can't pin shared memory. So like, it's at least two transfers to get that onto the GPU correctly. Um, so like, you're gonna cap basically at a few gigs a second. You don't actually get like the ideal PCIe speeds. So anything you can do to keep that relatively reasonable is gonna yield dividends. Is there a quick guide on how to make a simple env in C or Python other than the sample env on the site, which shows squared glue code for the CN? Yes, there is, but you have to open the HTML file yourself because it is in the 3.0 docs that are going to launch with the new code base. So if you go to PufferTank here, there's a 3.0 branch. This has new docs that are way better. I've had a lot of people complain about the docs. I'm not good at that. I did it better with 3.0. I just ripped off the way that Raylib does their docs because Rayson is a god. But if you just go here, you go into not this one, my bad. Puffer.ai, not PufferTank. PufferTank is our Docker. Where is it? Huh? Oh, dev. Okay, so if you open up this file, I'll put this in the chat. This has a guide that has all the links to very cleanly commented sample env code, and there are two envs there's squared in C, but then there's also target, which is multi-agent. So we have multiple sample envs, and they're nicely commented now. I can link stuff in the chat. It's just that you guys sometimes can't, because sometimes YouTube blocks it. Yeah. So we're very happy to like help people get started on this stuff. I do put in a lot of work to make it easier. It's just like, man, if you know how hard this stuff was a year ago, it's come down, like, it's 90% easier than it was. There's still a little bit of jank here and there, but it's like, we work really hard to try to make it easier. Okay, this works. Oops. Now, see, I forgot that I didn't want to paste that. Okay. Oops, 1 second. Okay. Cool. We've got this running. I'm gonna put this over here. So I've got now multiple people. All right, guys, I'm gonna drop off this. I got more people bugging me about meetings, of course. We do have quite a few people on the stream though, so Puffer AI for all the things, Star the Repo really helps us, and just join Discord if you want to get involved with all the dev. More experiments, 3.0 release, hopefully.